So this is, I mean, this, if they asked you this is horrible. It's nice that they've shown you what the answer is, but this is a good 15-mark A-level question. Comfortably.
15
At least 15.
If you get it wrong, that could be like 2 grades. Like.
But you'll start it. It's the bits, as I say, the bits at the end that are hard. The actual integration bit, using the formula, isn't hard. This bit of integration over here, you need to think carefully about, and then simplifying it to make this, that's quite a bit of work. So, it's by parts again, because I've got 2 things multiplied, and there's no substitution I can use that and make it work. Looking at the 2 things I've got, x and log of x plus 1, I mean, x I can differentiate and I can integrate, so I'm not worried about that, but what about log of x plus 1? Can I integrate log of x plus 1, or can I differentiate it?
Integrate it.
What's the integral of log?
Oh, 1 over x.
No, you can't integrate it.
Can't integrate it.
Yeah, isn't it like...
No, you differentiate it.
You differentiate it. So you can differentiate it.
Wait, why can't you do 1 over x?
If you differentiate log, you get 1 over.
Yeah, but if you integrate it...
If you integrate 1 over, you get back to log. To integrate log,
Yeah.
okay. So we can differentiate it. So this time we have to let u equal log of x plus 1. And v dx is equal to x. And then, as before, I differentiate and I integrate. So I get x squared over 2, and differential log of x plus 1? 1 over x plus 1. So that's 5. And then we just swap everything in. So
Are we just going to substitute x over 1 or something?
no, not quite. So we end up with, so we've got uv, which is this times this, so x squared over 2 log of x plus 1, minus the integral of this times this. So I'm going to write this out to begin with. So that's the first bit. You'll pick up quite a few marks just for getting that to that point. But it's this integral over here which is going to cause the problems. And to be fair, this integral isn't anything more different than the C2 one, but it's how you deal with it.
Would you put 1 over 2 outside?
I would definitely put the 1 over 2 outside. And I'd rewrite this as x squared over x plus 1 dx. So that's good. Now the x squared over x plus 1, as I say, it's not difficult, it's just how you rewrite it, that's the problem here. What could you do with x squared over x plus 1?
Could you bring x plus 1 up next to minus 1?
You could, but then that you, so what you're suggesting is x squared times by x plus 1 to the minus 1.
Yeah.
But then how...
Oh no, you split it up and divide by x.
Split it up, no, can't do that either, so you could rewrite that as... That doesn't work either, nope.
Can you not just take off 1x?
Can you not just take off 1x?
No, not like that, but is there like x? No. So like x over 1?
You can't then. No. So what you've got to do here is this is a top-heavy fraction, agreed? Because the power here is bigger than or equal to the biggest power on the bottom. So the best thing to do in this case is to actually divide out. Sorry?
Yeah, that's
Yeah.
what I would want.
Now, if we're dividing, I need to put some stuff here. So I'm going to put 0x plus 0 as well. And how many times does x plus 1 go into x squared? X. So I've got x there. I've got x times x is x squared. X times 1 is 1x. Subtract minus x. Bring down the plus 0. What goes there? Minus 1. So I get minus x minus 1. So I get a remainder of 1. So I can then rewrite this integration as follows. So x squared over x plus 1 is equal to x minus 1 plus the remainder over x plus 1. So I was actually lying about being C2 looking at it. But so you divide out, and now this thing here I can integrate. So if I now look at this, I'm going to put square brackets around everything now to show that I've finished the integration process at the end of this bit. So what's the integral of x? X squared over 2. Integral of minus 1. Integral of 1 over x plus 1.
X plus 1.
Then x plus 1. Good. And that's between, sorry, e minus 1 and 0. Right, God, somebody's going to ask something about that.
I put the integral thing over around everything.
Oh, why I put the square boxes around everything?
Well, absolutely everything.
Because at this point here, I've still got something I've got left to integrate.
Yeah.
So what I'm saying is, from here to here, I'm now in a position where I look at that and I know I can integrate everything in that. So I can figure that out. So I'm going to put square brackets around everything to show that I've done all the integration.
But you didn't. But you haven't integrated the first bit, so why is
That's already been integrated. That's done already. The only integration I've got left to do is these bits here, isn't it? Yeah. So
Why do you have to divide?
why do I have to divide over here? Because here I've got top heavy.
So,
And if it's top heavy, the easiest thing to do is divide out, and then you will get some. You can't integrate that as it stands. How would you go about integrating that thing?
no, I think you can't integrate that, I agree.
Yeah? Good.
Phew.
So from here, I'm looking at this, and I can't integrate it. So I have to think, okay, what else can I do, possibly to integrate?
How many times it fits into that?
Exactly right.
Let's say x minus 1 times.
Yeah,
And then,
with a remainder of 1.
yeah, and the remainder is 1 over the thing you would divide.
Yeah, exactly. And by doing that, I can integrate this, I can integrate this, I can integrate this, so therefore I can do it. So it's just one of the techniques that you need to think about if you get to a point where you've got something to integrate, you can't quite think how to do it. So okay, top heavy, I can divide out, let's see if that works. And there are other things. If it's a trig function, there's identities you can use. You might think of partial fractions in that kind of position as well, but there's all kinds of other techniques which you need to think about.
One thing I would get, I wouldn't come up with how to that you have to divide it.
Well, that's it. I mean, it's a good question for Vara. There is. I got to this point. Oh, I still don't know how to do it, and that's why I thought it was a good idea to do the example, because by seeing it, then you're more likely to remember should it ever crop up in the exam situation. But you're right. Given that that's the first time you've seen it, and had that been the first time you saw it in an exam, then you're in trouble because you might not have the skills and techniques. Fingers crossed, you do now. But anyway, I haven't finished yet because I still haven't proved it's to this thing over here. So the next thing I need to do is swap an e minus 1 and 0. So let's see what I get.
So do you have to do all of that and put e minus 1 into x and then minus it, put all of it in again?
Correct. Yeah. This is why I said it's worth a lot of marks, because it would be. So I've got e minus 1 squared over 2 times by log of e minus 1 plus 1 minus a half of...
I don't think that this into exam would be quite unfair because the people who would just by chance happen to do it, because they may just have like a lucky lesson or something, will like get way too big into it.
So that's the first bit. Well, it might be unfair, but hey.
If I wanted,
It's only unfair if you don't know how to do it, but if you know how to do it, then it's very fair.
Is it e to the minus 1?
So it's e minus 1, no, it's e minus 1, e take away 1.
Well, how do you put that in your calculator?
You wouldn't, because they've told you what the answer is. And if you put it in your calculator, you're just going to get a long string of decimals. So calculator is no use. You have to figure it out. Now, it might look horrible, but there's a few things straight off that we can do. What's the value of 0 squared over 2 times by log of 0 plus 1? 0. So that goes.
How do you know?
Because anything times by 0 is... Okay. Okay, 0 squared over 2? Goes. 0 is obviously 0. What's the log of 1? 0. So there's all this second bracket is...
E minus 1, 0.
No. I'm looking at this when I put 0 in.
Oh, minus A.
All of these become 0. Look at the top bracket. What's e minus 1 plus 1? E. And what's the log of e? 1. So all of that is 1. And then similarly over here, all of this is 1.
And it's log 1, 1.
Log 1. Log of e is 1.
Log of E.
Log of e is 1. So let's have a look, see what we've got left there. So I've got e minus 1 squared over 2 minus a quarter. Let's not do a quarter actually. Let's do e minus 1 all squared over 4 minus a half times by minus gives a plus, so plus e minus 1 over 2 minus a half times by this is minus a half. So I can see already that I've messed that up, and that needs to have a minus a half at the end. Oops. Now, there's lots of stuff you can do. Yeah, just make the question as you go along. Why not? there's lots of stuff you can do to this to make it look
Take out
like
the
this.
number. Oh, so
First thing I would do is what's a half of e minus 1 squared? Take away a quarter of e minus 1 squared.
Quarter.
Quarter. Quarter. So that's simpler. Not too much worried about the minus a half bit, because obviously that just came. Looking at
half
this.
minus a quarter, a quarter.
A half minus a quarter is a quarter, yeah.
Oh yeah, that's right.
Good. Now, these two things here have got a different denominator, so let's change the denominator to be the same. So what the denominator?
Times by 2.
4. So I'm going to change that to 2 over 4. And the next thing I'm going to do is, what's a common factor now between these two fractions? E minus 1, yeah, over 4. And in the bracket,
Times by 2.
no, this
E minus
E minus 1
and 2.
plus 2.
Wait, what?
So if I, E minus 1 times by E minus 1 is E minus 1 squared.
Yeah.
E minus 1 times by 2 is 2 e to the minus.
Yeah, okay. But how do you know to not do like e minus 1 times e over 4 and e minus 1 times
You could do that. You could expand it all, but it's going to take you a lot longer.
E minus 1 times.
So E minus 1 times by E minus 1 is E minus 1 squared. So that's that first term sorted out.
Oh, so we're just splitting it up.
Exactly. And E minus 1 times by 2 is 2e minus 1.
No, you lost 1 second there.
So these two separate terms,
Yeah.
if I do this times by this, I get the first term.
So just splitting up the first term.
Yeah.
Then why isn't that over 4 as well?
Well, it is over 4, so I changed it to be over 4.
No, but the one underneath.
So, I'll come back to it. Let me just finish it off, okay? So I get e minus 1 over 4. This becomes e plus 1. And I end up with this times by this is e squared. Minus e plus e is no e's. Minus 1 times 1 is 1. So I end up with what it was. As I say, I'm ignoring the fact I forgot the half.
Yeah, but so you just don't have to write another line in between.